Welcome, dear friends and colleagues. Welcome to Flight Simulation. This is Prepar3D, which is next generation of flight simulation. Company Lockheed Martin bought a game engine from Microsoft and continued developing. And right now they're releasing. Currently they're releasing 64-byte version. I'm using 32 bytes, so yeah, probably a little bit slower in terms of FPS and everything. We are currently at Munich airport in Boeing 737-800 cockpit. This very representative and pretty much the same as real cockpit. Add-on is brought to us by PMDG, not very relevant. And yeah, idea for this simulation is not to follow procedures and be too serious, but to show you how this simulation could be interesting. And with flight simulator you can fly everywhere, download airports and airplanes, and do whatever you want and feel how it's like to be a pilot. Yeah, it's boring sometimes, I warn you. Today we're gonna fly from Munich, as I said, to a Frankfurt airport, and we're gonna start by simple things as turning on our batteries. As we can see, we have some electrical power, not enough for air condition and starting engines and stuff, but just for the start. For saving time and get more power, I will turn on APU. It's sort of auxiliary power unit. That is actually a little turbine in the tail of the airplane that use our fuel and generate electrical power. So it's pretty much a generator. Yeah, but it's not working on diesel. In the meantime, we're gonna enter our information of fuel, and actually we're gonna, by entering this information, we will tank our airplane. Oh, sorry. We need 10,556. Let's just go with 11, just in case. Yeah. Pounds of fuel. It's expressed in pounds. So by entering this, it's spread to two tanks equally. Center tank is empty. We can change that, but for the simulation, it's okay. Also, at where if we put our finger, we will get balance of the airplane. So let's just go to the payload. Okay, payload is actually our cargo weight plus our passenger weight. So we're gonna have, let's say, 12 passengers in business class and first class, and let's say in about 105 on coach class, or in other words, economic class. Our cargo, we will leave the cargo, it's 4,000 on forward and aft cargo space, and our zero fuel weight has just changed. It's now 123.1, and center of gravity is 15.8. Let's go to now real FMC and to position initialization. Okay, we need to enter some positions over there. We don't have space for it. So what we have to do now, we have to tell our airplane to use electrical power from APU. APU is started, but we need to switch and use electrical power. So let's do that. Okay, we hear the air condition is coming on. Everything works smoothly. So next step is to set our IRS. IRS is inertial reference system. It's very sophisticated and complicated device that consists of a lot of instruments such as gyroscope, inertia measure, and everything. It's, I don't know, it's something like GPS, yeah, but not really. No, it's not like GPS. Actually, it's measuring device that measure some forces of the airplane, and by measuring that forces, it moves our airplane on the map. So let's turn it on. It will take a couple of seconds or maybe a minute to align. In real life, it takes about up to half an hour to align. So be patient. Okay, we have some warnings, but it's okay for now. Okay, so we need to enter our RS position. In terms of latitude and longitude, we don't have those, so yeah, we have it over there as last position of the aircraft. That was before this, so we're gonna use the GPS coordinates. We have two GPS receivers. Everything on airplanes is doubled in case of one device or system fails. So we have our latitude and longitude in that nomenclature and just set it over there. And yeah, we now have our horizon and navigation. We don't know actually, we have coordinates, but we don't have any other information of our airport. So let's go there and tell system where we are. So let's define our route. So we're gonna start from Munich. It's EDDM. It's ICAO code for the airport. Every airport has one and it's unique. And we are going to EDDF, which is Frankfurt. Okay, let's go and select our departure routes. Those departure routes are defined by airport and air traffic control and flight plan actually, and usually air traffic control tells you which departure route to use, and you set that, meantime, blah blah blah. And right now we're gonna use very short route, not really the one which we're gonna use in real life. We have some graphic glitch here, but it's jetway attached to us, so let's use departure and select for example, yeah, let's do 26L runway, and let's choose our next path, which would be next waypoint. Actually it's BBAT12S. Let's do this. Let's see where it is. Okay, so yeah, it's not really in the direction of Frankfurt. Let's choose another one. Let's go again. Choose another one. Let's see where is key. I'm not really sure. I'm not familiar with those with Munich departure routes, so we'll just have to improvise and use some. Yeah, this looks like something promising. Let's check a little bit if it's right. Yeah, it's okay. It's a little bit forward, but it's okay. And we will click the route and click activate, and by that we will just have to confirm. so we're definitely going to use that departure. And let's select arrival for Frankfurt. We're going to land on 7. Let's do 7. Let's do another one. Let's do 25C. Yeah, that's fine. And use CHA for arrival. Transition. And let's use some star maybe. It's yeah, just use PSC 3B. Okay, let's check our complete route. We see that we have something strange here. It's called route discontinuity. That's because I didn't use official routes and pathways, so I really, in real life, I had to put some in-between waypoints, but I will skip that and patch it and say it's okay, we just wanted that. So we have some lack of information here, and yeah, we have some lack of this. I know that because it wasn't on load sheet. And cost index is performance index of our airplane. The larger the cost index, the performance would be better, the engines will run faster, I mean in more throttle and thrust. So yeah, the lower the value, the engines are spared of amortization, and we'll just use the maximum one because it's simulation and we want a full power. We're gonna our cruise altitude would be 15,000 feet. It's called also flight level. No, sorry, not 15,000 feet, my bad. We're gonna use 20, so it's too low. We're gonna use 20,000 feet. 20,000 feet. It's called also flight level 200. Okay, let's go on N1 limit. We're gonna skip this. Let's go to the takeoff reference. So we're gonna use flaps 5 degrees for takeoff, and our center of gravity was 25.3. I remember that. Even if I'm wrong for 1 decimal, that's not a big deal. And we have our takeoff speeds. So we have V1, VR, and V2. What are those? Those are speeds, different speeds for mean different things for takeoff. So V1 is a speed after which we cannot abort our takeoff. So once we reach the speed, it's assumed based on our runway that we might not gonna succeed in our stop or the airplane. So yeah, we'll accept that and select next one. It's VR, and VR is speed of the rotation, which means that once we reach that speed, we will just pull our yoke in towards us, and airplane will go off the ground. So next one is V2. V2 is the speed that is used in case that one of the engine failed during the takeoff, which can happen. We have some burning enabled to do some speed at one point. It's okay, we'll skip that. So we have our takeoff speeds. What's next? Yeah, we definitely have to power on some hydraulics on this airplane, because for some reason we cannot, as you can see, without hydraulics we cannot even move our wings, I mean our ailerons and everything. So we need some hydraulic pressure. Let's do that, and first turn on the fuel pumps. We can hear them squealing. On the emergency light. Yeah, we hope that we don't gonna need that. And yeah, I will skip that seat belt sign and everything for this demo, and turn on the hydraulics. As we can see, by turning on the hydraulics, we can now move our wings and ailerons and everything, and rudder and stuff. So yeah, what's next? Let's set probe heat. It's okay. At high altitudes it's a little bit colder, so we need some heat over there, not for the ice but generally. So next step is setting our cruising altitude for pressurization, so also setting 20,000 feet, and our destination airport altitude is 250. It's about above sea level. So right now we can turn on our collision lights and request pushback from ground control. Okay, let's do that. Our runway is on our right, so we're gonna need pushback to the right. First close the door. Yeah, and since we have jetway, we have to signalize to detach our jetway. So as we can see, it's slowly coming up to opposite direction from us. Yeah, and as I said, request pushback. So let's go to pushback and say we have to do it right in 90 degrees. So let's request pushback. Now we will hear some simulation of the pilot voice and talk with the ground. I will mute for that time. Okay, let's start.
And ground cockpit.
Go ahead, Captain.
We're all set to go up here. We've been cleared to push and start at your discretion.
Roger that, ready for push. Power and air are clear, doors closed.
Okay, parking brake is off, cleared to push.
Okay, we'll now, after the push, we will start our engines.
Brakes off, here we go.
As we can see, we have started our pushback. So I will start both engines. Usually it's pilot start one by one, but to save some time I will start both engines. I mean, it's not really start, it's ignition of the engines. Not really even ignition, it's called let's see, I always forgot that. Yeah, start switches. So right now we are starting our turbines and getting our air from the APU, still from the APU, and once those numbers reach 2.9 we're gonna release fuel in engines, and we can see our exhaust temperature is quickly rising. Meanwhile, we're gonna set on MCP. This area is called MCP, and we will set our flight directors and turn on auto thrust. It will be used immediately after takeoff, and our maximum speed. So this speed will be used once I turn on the autopilot. So, or even in case I don't turn on, but okay. And one more thingy. Also, I will have to use maximum altitude as for reach altitude. If ATC, air traffic control, says that we climb to, after takeoff, climb to
Push is complete, set parking brake please.
Okay, to 6,000 feet, we will set 6,000 feet, but in this case we don't have air traffic control, so we set to maximum, cruising altitude. So we were asked to put our parking brake on. We're going to do that.
Alright, brakes are set and pressure's normal.
Okay, sir, tow bar is off, pin is out. Watch for the pin on the
This is the parking brake actually. It's
Alright, guys,
lighted,
thanks.
so
You're
it's
clear
on.
to disconnect. We will be watching for the pin and the release from guidance on the right side of the airplane, and we'll see you guys next time through.
Roger that, have a good flight.
Okay, so what's next? Okay, we don't need APU anymore. We have our power generated from our engine, so we're gonna use power from engines. We just turned it on, and we can now turn off the APU and turn off the APU bleed. APU bleed, I will just bring back that overhead panel to be simpler. APU bleed is actually air from APUs. Since we turned that APU off, we don't need bleed, and we will use air from turbines on engines and turn on our left and right packs to give us air conditioned air. So not so bad over there. Nothing is light up. No reds, no orange indication, so it's good. We can now check our flight control. We'll do that very quickly. Okay, so try it on the left, try it to the right. Usually you see that by your window near the wing, and I will switch to outside camera on the wing to show that. So if I move on the left or the right, yeah, you often see that right before pushback. That means the pilots are doing that thingy. So let's check. Left, it's okay. Right, it's okay. We have our feedback from hydraulics. And yeah, and up and down and rudder check. Left, right. Our parking brakes are fine. We're gonna release them right now. It's okay. And two next things to do is to set flaps and everything, but I will do that on the before takeoff checklist. I think it's fine. Yeah, what I can do now is to set auto brake to. I will now set flaps auto brake. Usually it sets at this point. So I set the auto brake to reject the takeoff. In case for some reason we want to reject our takeoff before V1, I mentioned, we just release the throttle and auto brakes will immediately switch on, and we'll have automatic braking. So I have to set the flaps to 15. As we can see on this indicator, it's going to 5. Set the flaps to 5, so it's going to 5. And we can see that also on outside. Sorry, as we can see, flaps are going down, and yeah, they're done with that. So okay, we did pretty much stuff. So we can go to the taxi, to the runway. So we'll turn the taxi light on and start our taxiing. So we'll go just in the front, and yeah, we'll see where is the runway. I'm actually not familiar with Munich airport. I flew to Munich from Munich just a couple of times. I mean in simulator. Yeah, also thanks to my company ISAM. Yeah, I flew also in real life, but not in cockpit, unfortunately. So yeah, we can have some side view on Munich airport. Yeah, it's wonderful. So let's see, our ground speed is 16 knots. we won't go over that. Maximum on taxiways near the runway is 30 knots. It's very fast. It's about actually 40 miles per hour. It's not sorry, 35 miles per hour or something, or in kilometers per hour it's about 40 kilometers per hour, which is a lot. And we're going 23 now. I will just brake a little bit because we have right turn soon, so yeah, let's do that. Let's do our magic. So we have this little bridge above the, I think it's highway or just some motorway near the airport. I think we all saw that in Munich. That was very interesting. So let's go over there. Yeah, I think it is actually. Yeah, it's a little shitty graphics, but yeah, you can imagine what it is. Probably it could be better, but even now my frame rate is 24, so by setting a little bit more, obviously it will make my computer crash or just get a shitty frame rate. Let's go in this direction. It's towards our, I would just push a throttle a little bit so we can gain more speed. Yeah, it's above 31, but it's fine. As we can see, we are rolling pretty fast on a taxiway. But yeah, we don't do takeoffs on taxiways. I heard some Canadian pilots tried to do a landing on a taxiway. Fortunately, that didn't went. It was on, I think it was on Kennedy International Airport. I'm not really sure. So we are a little bit slowing down before our turn. Soon we'll perform a little checklist. Usually, I mean, right now I skipped a lot of checklists, but this one is pretty much important because it's just before a takeoff. And in past, I used to forgot things like flaps and even the doors. I once forgot to close the door because I didn't use some add-on called FS Passengers, which simulate flight attendants and passengers and everything. So there was nobody to shut down the door, to shut the door for me. So I was, yeah. I mean, I knew that because once I tried to take off, I saw the warning on this area, and immediately I know what it is. I knew what it is, so. Yeah, let's just slow a little bit, and we're gonna make a right turn towards our runway, and we're gonna reach holding point, which is indicated by, not this one, by dashed and not dashed line close together. Close together, and yeah, this is not yet. I mean, this is one of points, but this is the holding point just before entering the runway. It's usual for the air traffic controllers to ask you to stop on the holding point before they let you to do a takeoff by say clear for takeoff. Okay, so let's do some final checks. Okay, this is a quick checklist over there. It's are larger in real life, but it's I mean, Boeing 727 have this quicker checklist, let's call it that. So let's move this knob and go step by step. So config, takeoff config, we did that. We did that, and recall, yeah, we did that. Flight controls, we checked those. Flaps are extended. Step trim, yeah, we didn't use the step trim, so let's do it. At initial performance reference, we have trim 4.39, so we just have to step our trim 4.39. Okay, that's it. Okay, next step is takeoff briefing. Yeah, let's say we did that. Cabin pressure, let's check it's okay. So starting switches to continuous. Okay, starting switches have to be continuous. If one of the engines for some reason turn off, it will immediately restart the turbines. I mean, just doing some rotation, and engine will restart immediately. So it's used in takeoff and usually on some turbulence area, weather. So transponder, yeah, MCP area, we set our values over there, it's fine. And transponder is a transmission device that transmits our squawk code, which we get from air traffic control. We don't have that, so we'll just think of something beautiful for our squawk code, and we have to put this switch to TARRA. It's used for TCAS. TCAS is device that detects airplanes nearby and warn us if we are on the same path, and even pretty close. So it's traffic collision avoidance system. I think it's that short. Okay, so let's put it on the TARA. Auto brakes are fine. Let's go to the next step, landing and strobe lights. Alright, landing and strobe lights. Landing lights on, turn off the taxi lights. We could leave it on, but okay. And strobe light is over there, so position strobe light. Okay, those are some blinking lights on our wings. We have to use that during our takeoff. So yeah, let's say we are fine, we are good, and we can go to the runway and perform takeoff. And no, we are not immediately setting full throttle over there, because that would be disastrous for us. We're not full with cargo and passengers, so we're gonna increase our speed very quickly. So let's do a full throttle, and here the engine's on the full throttle. Let's do that. Yeah, that's familiar vibrating sound. Obviously it tells us that we have pushed our engines to the limit, so we won't gonna use full thrust all the time. Obviously it's bad. We're gonna hear V1 pretty soon, and V rotate.
V1 rotate.
So yeah, we are starting our climb. Okay, great. We have positive rate of climb, so we will retract our landing gear. Let's put our nose a little bit up. Yeah, it's fine, it's good. So yeah, let's see some scenery over there. Yeah, it's Munich, obviously. So yeah, our speed is going up, so we can We can retract also our flaps. Let's do that. Okay, we are just waving on the right, so we'll just need to. I'm still riding this. Flying this plane, flying this plane manually, which is okay for now. But I really can't fly all the way to Frankfurt. So right now I will push this autopilot button. So autopilot is on. Okay. But that's not enough. We're gonna use our flight computer indicated path and vertical navigation. So as we can see, we're gonna start. Yeah, we're just aligning to that path, which I was off obviously a little bit, but that's okay. Okay, landing lights are sorry, not landing gear is retracted. Flaps are retracted, and there is an auto brake. We're gonna use that off, and right now we can switch back our start switches to off. Let's see where we are. Oh, we passed the 10,000 feet, so we can turn off the landing lights also. That's great, and that's fine. We are climbing with a good rate. So what I'm gonna do now, yeah, it's a beautiful sight, isn't it? I'm not sure if it's a real and good representation of Munich. This is add-on Munich airport. Usually all airports in Flight Simulator are auto-generated and not really not really representative in terms of real life, but taxiways and runways and obviously paths on the all airports are good in comparison to real life. So yeah, we have some lake over there or something. So yeah, we are now probably on, yeah, as I thought, about 15,000 feet, or in other words, flight level 150. Usually it's pronounced flight level 150. Yeah, that's. So we're still climbing. I want to climb a little bit more in more angle. So we can choose in the climb section to maximum rate. It's, I don't know, it's some average and optimal. I'm sorry, it's optimal between rate of climb and speed. So we can use maximum rate or maximum angle. I will use maximum angle and execute that, confirm. So this, our speed will be a little bit lower, but we will get a better climb. Of course, we set this speed, but our flight management computer calculated that at this climb our speed will not go below 253 knots. So yeah, we can see another airport over there. Yeah, let's see which one is that. Okay, turn off the airports. Yeah, I can't see that because it's behind us. I can't rotate. I mean, I can rotate actually. Yeah, I can rotate. Who I'm lying over there? Okay. Yeah. Let's see what airport is that. We have this navigation thingy show us airports, terrain representation, and yeah, as I said, airports nearby. So let's see what's that actually. Yeah, that's our airplane. Yeah, good, great. Yeah, we have a lot of them. Okay, let's go back to Okay, we see after some point we will start to go right. In order to save time, I will immediately go to the right. Yeah, we see on the left side there's some green dots and green shaped, green patterned area, which means those are that's indication of the mountains of our left. We can see them on distance, but their edges are not danger for us, so that's why they're colored in green. Yellow is some kind of warning and proximity, but red color is definitely no go. So let's just skip this waypoint Ola SO and go immediately to CHA. I think I messed something up, so yeah. Let's go immediately to CHA, and our airplane now will start turning to the right. Great, let's see our wing view. Oh, it's great. We have some mixture of texture because it's still calculated that somewhere would be snow, but yeah, it's a computer game. What did you expect? Okay, we have everything on our side, and we climbed to our cruising altitude. So right now we can use a little bit economic thrust, but I will leave that to automatic. So everything now is controlled by autopilot and our flight management computer, which means we actually doing nothing right now. If you expected that pilots really control the airplane all the time and all the way to the airport, you were wrong, deadly wrong. It's all computer. Everything is computer. But the funny thing is, Boeing 737 computer, which looks so sophisticated, was actually built 30 years ago, almost 30 years ago. So keep mind on that. Those days were days of engineering. We see some mountain or hill edges over there. Let's see. Yeah, we see something in the distance. Looks like the forest over there. So let's do a quick overview of things we have here, one by one. I will not go to all the things and all the knobs and switches and blah 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 over there. Especially I won't bother you with stuff over there, but let's do something else. On the left side we have a clock. That analog clock isn't really a real time zone clock, it's just a clock. You can set that clock on any time zone you like, but the real thing about this clock is that flight management computer is synced with that clock, which then means that all prediction of arrival times and waypoint arrival times are compared in essence to that clock. So I will go to that clock back a little bit later when I talk about FMC and stuff over there. So the next panel over there, next display, showing us, as we saw before, our speed on the left side. So that pinky thingy over there is actually our set speed. It's above I think flight level 180. It's displayed in Mach number. It's 0.73 Mach. So it's 0.73 speed of sound actually. Yeah, we cannot reach that, sorry. But everything in the red zone is too fast for the airplane, and our airplane construct cannot stand that, so we don't go over there. In the middle it's our artificial horizon. So at the center and at the cross of vertical and horizontal line, it's our planned path. So as we traveling using autopilot and computer, it's obviously ideal. Okay, and we have representation, visual representation of the wings and nose position. Right now we are, nose is okay, it's going forward a little bit. I mean, it's about 2 degrees or 4, actually it's 4 degrees before, because we set trim over there, so it's about it's not 4 degrees, yeah, but it's something like it's a couple of degrees on the up, so because airplane isn't actually go straight forward, it's always a little bit up on the nose position. So on the right we have our altitude indicator. We have over there in pink color our desired and set altitude, which we set that over there. So also we can see on that on this bar over there our set altitude. We are just about 40 feet above. It's not a big deal, yeah. And I just resetted the barometric pressure in the knob. It's not a big deal. I will not talk about that now. So, and on the very right we have our climb rate indication, so, or descent rate indication. It's actually vertical speed indication. So what it means that 1, 2, 6, it's 1000 feet per minute, 2000 feet per minute, and so on. Right now we are going straight, almost straight forward. We always swing a little bit up and down. It's not a big thing. It's always it's like that in real life. So yeah, that's our one of the most important panels. Right over there it's our navigation panel. It's actually very interesting thing. So on navigation panel we can do a lot of things. On navigation panel we can see our flight route, go through them, some check out position in alignment and in communication with landing instruments, blah 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 blah. No, I will not bother you with that. So also it's showing us our flight path, and we can see other airports. Also we can turn on to see other waypoints over there. I will turn off the airports right now, we don't need that. So we have some radius lines over there, and each section displays some distance. So 40, that middle circle over there, displaying us the distance of 40 nautical miles, and it's 20 nautical miles, and over there it's 30 and 40. Sorry, 60 and 80. This is our direction course. This is our next waypoint, and nautical miles distance. You can see it's decreasing. We're going towards it, and arrival time. So now we're going back to the clock. 7:41, which means we'll be there in 11 minutes. Great. We are fast. We are furious. Okay, and we have that little indication over there. It says TD. It's pronounced top of descent. What it means? That means that at this point we will start our descent. Okay, in the middle we have backup instruments. Those instruments are could be used when everything other fails. When every display which requires some large amount of power and everything fails, that little display that relies just on battery power will stay on. And this navigation analog, let's just call it compass, but it isn't, we can use to navigate through using NDB, ADF, and VOR, and blah blah blah. It doesn't mean to you anything. I know to use navigation. That's something that is more used in general aviation than on airliners, but everybody knew that. And of course, yeah, we have over there display of our outside temperature. Since it's -1, we could use some anti-ice over there. Why not? So let's turn on some anti-ice and anti-wing ice. Anti-ice on wing and anti-ice on engine. We can see our engine thrust indication, exhaust temperature, fuel consumption, and also we can see vibration on engines. We can see that our left engine makes more vibration. I don't know why. Oil quantity, oil temperature, oil pressure, and yeah, we have two blades and turbines over there, so we can measure the performance on both of them. And we are closing to our stop of descent, so we'll just now use. We have to lower our altitude on MCP. It will not immediately go into descent. That's only a setting. So we can see our pinky bar is down there, and I really want to start my descent now because I don't want to go too steep. So let's initiate descent. After I click this, our nose will go a little bit down, and yeah, we can feel that. And also, oops, sorry. Sorry. We can feel that, and also we can see on vertical speed indication that we are descending in 1000 feet per minute rate. Good. Oh, look, there's our airport in about 60 miles. 60 miles, it sounds like a lot, but really it isn't. We'll be there very soon. In order to help with that, I can turn on the speed brake. Yeah. So it isn't actually going faster. Okay, what is speed brake? Has its name called. It's using air. I mean air drag, air force to actually slow down the airplane. So let's go on the wing view, and we can turn on the speed brake, and we can see those plates are coming up. And meanwhile, on our descent, I will show you some other things very quickly. So right here we have, as I said, subtrim, speed brake, parking brake, cut-off switches for fuel. We don't want to push that, sorry guys. And this little red panel is the panel we don't want to light up. It's for the fire on engines and APU. It could happen. I will just do a little test and show you how it would sound like and be like if we have some fire on board. Yeah, not very funny. So we have our radio stack panel. I will use the 2D view for explanation. So over here we have communication frequencies that we use from tower to tower. I mean from ATC to ATC. We have a lot of coverage and departments from ATC. Down there, just below, it's ILS frequency panel. We'll use that on our approach. Over there it's volume buttons, antenna buttons, blah 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 blah, not important. Some other navigation frequency for NDB, ADF, actually for ADF, sorry, and so on. It's not important really for this little demo. So what we have also, this is weather information panel. Yeah, we can show our clouds on the board, but yeah, it's not very interesting. Down there we have switches and knobs for lighting up the panel on the dark. Radar trim, we use that if we land without one engine, so one engine will not cause the thrust, but it will cause the drag. And yeah, there's also a knob and knob switch for flight deck door. Okay, right now we are at 14,000 feet. We are actually, yeah, I think we'll be ready pretty soon. Okay, so also we can see beautiful scenery over there, some fields, cornfields actually. So let's go next. On this side we have, as I said, we can set our speed, our heading. If we want to use heading, we can press heading select. I will just now show you a little bit of that. So let's just say our heading, you can see indication over there. We just want to go to heading 043 of 023, heading 23 actually. So if we push heading selection, we're gonna immediately start our turn to the right. So we don't want that, so let's go back to navigation to use a flight path for computer. So we're going back. Also there is a manual selection of vertical speed, altitude hold, VOR lock, we will use that, and approach and glide slope lock, we'll also use that. There's also autopilots, primary and secondary. We use secondary for landing, not mandatory, but for automatic landing it is. I will turn on speed brake just to get a little bit drop speed over there, because we have to reach that point over there with certain speed and altitude. We have to make sure to do that, we're gonna be able to do that. Okay, so yeah, I can show you quick overview of the overhead panel. So overhead panel over there. Over there we have some battery section, some navigation section, and displays. It's basically divided into electronic section, you know. It's over there, everything there is electronic. It's electronic pumps, it's electronic bus switches, so it's all about electronic over there. This bottom panel is all about light and of course ignition switches, start switches, seatbelt signs, everything. So over there it's probe window heat. I didn't use window heat, but it's useful if the outside weather is too cold and you want your windows to be flexible and everything. So also we have anti-ice that we used, and wing anti-ice. Also we can set this one over there is all about pressurization and temperature and cabin accommodation. So we can select temperatures for different areas of the airplane, manage the pressurization, see the actual pressure, and so on and so on. So let's see where we are. I have to lower the distance view and see that we are still on 5,000 feet. Let's see what it gives us. Okay, we are simply not good enough. We have to increase our descent rate, so we'll just manually do speed. I will lower a bit speed a little bit and use a speed brake to do that. but in essence I will increase our descent rate to 2200 feet. So as you can see, our speed is slowly increasing, but I will lower our descent rate once we reach nearly 50 knots. Yeah, we see some city over there. So let's see. Yeah, we are close enough. So I will lower a little bit our descent rate. Let's say to 1.5 to 1,500 feet per minute. Let's just do a little bit more than that. Okay, so we are descending. We really need to descend a little bit more, so I will just use a little bit more of descent rate. 6,000. Okay, I think we are good right now. So I will lower the descent rate to 1,000 feet. For now, of course. Yeah, maybe a little bit more. Yeah, I think we'll be fine. Okay, we are slowly decreasing our speed, and this indication, this cell, tells us to decelerate, and we are just doing that. On the right we have some mountains over there, but not dangerous for us. It's too far, it's too low. Still we are using speed brakes, as we can see on our wing view, but pretty soon we will just turn that off. So it's time for our approach. Yeah, let's see our approach. It's notification, we have to select our approach speed, so let's do that. And yeah, of course, outside temperature is above 10 degrees, so let's turn off the anti-ice. Okay, our ILS approach frequency is 111.55. Let's set that 1111.55. okay, and put to active. I will turn on the volume, and we will probably get some Morse code from ILS, which will tell us that we are on good frequency. Yeah, we are good. Okay, we are reaching our left turn, and I think we have to be pretty soon on our runway alignment. So we see this little diamond. That's our glide slope path intersection. Right now our glide slope path is above us. What we want to do is to actually first lock to our runway path. Just use void lock. Okay, so we're making a left turn, and we can see, I mean we will see soon our little diamond over there going horizontally, and yeah, here it is. It's going to our center, and by that we are centering our position to the runway. Okay, we have indication that we are 2,500 feet above the ground, so right now we can lower our flaps to 15 and turn on the landing lights. Okay, we see the flaps are lowered, our buffet speed and maximum speed. So let's see what are our approach speeds. So if we use full flaps, which we will do, we can do 134 knots. So let's do it. Okay, let's lower our speed. We have to do that, obviously. Yeah, 54. Okay, next step. We're gonna soon intersect our glide slope. In order to follow that glide slope path, we need to turn on our approach switch. And by that, as we can see, there is a glide slope. It's live, it's there. It's capturing at the moment. And pretty soon it will be captured. Yeah, it's captured. Okay, right now we can lower our flaps, extend our flaps to the full. We are still a little bit far from the runway for lowering our speed this much, but not a problem. And we are lowering our landing gear down, so we'll get more drag. Yeah, this is our approach speed, so we can turn our secondary autopilot on. Everything is good except auto brake, and not only auto brake. So yeah, we don't want to really go to the end of the runway, so I will apply maximum braking. It's very hard, trust me. And I need my speed brakes deployed immediately after touchdown, so I will move that to the position armed. It will not extend speed brake at the moment, but only be prepared. So immediately after touchdown we will get some additional braking power from drag. And also I have to define our minimums. It's minimum altitude after which we have to decide whether we see runway and we continue our landing or not. So I need to set that, so I will set to 200 feet above the ground. Okay, I could choose between baro and radio. Radio means that I'm using infrared sensor to measure our distance from the ground. Okay, so we see some motorway down there, or it's highway actually, and yeah, we are going to land pretty soon. Those lights, there's 4 lights, it's called poppy lights, and when we have 2 white and 2 red, it means that we are on perfect glide slope path. Of course we are, because computer guides us. Okay, speed is stabilized, so I will now turn on the auto throttle, but my levers will stay on same position, so nothing will actually happen. And also after minimums I will turn off the autopilot once I got above 100 feet. So expect minimums very soon.
Approaching minimums.
It's not pilot voice, it's automated voice. Minimums has been declared.
100.
I turned off the autopilot.
50. 30. 20. 10.
And touchdown. So we are using our reverse thrusters. As you can see, once we applied all braking power, we are actually, yeah, I can turn off the reverse thrusters right now and continue exiting of the runway. And welcome to Frankfurt. I'm not sure if I'm on right direction. I think I am. Maybe I missed. Let me see in the distance. No, we are fine. Okay. Once I exit the runway, I need to turn on our APU again, because we're gonna turn off our engines later, and turn off the landing lights, and turn on the taxi lights. Okay, and I can use APU bleed over there, air from APU. I can turn off the window heat, and yeah, of course recheck the flaps. They're still lowered, so I don't want to leave them like that. Yeah, we use some electronic rotation engine, whatever. Ignore that. Okay, so we are at some gate point. Imagine that we just have been told from the ATC which gate to use, so we use that gate called 21. Yeah, we've just followed the taxiway path. What else could be wrong? And there is an indication display over there that will tell us our distance from point when we must stop. Just a little bit more. So I will just zoom in so you can see. It goes 12 meters, 9, 8, 7, 6, 5, 4, 3, 2. Maybe I stopped. 1 meter. Let's shoot a little bit more. Yeah. Okay. Just do it. Stop. And stop. Okay. We stop. We will just turn on the parking brake, and yeah, we need to tell our airplane to use APU power again. And we'll do just cut off the fuel, so we can see our engines are stopping. Yeah, and since we are now on the ground, you can see that airplanes nearby are just in yellow colors, indicates that they're too high from us. Of course, that's radar system, they don't know we're landing. So yeah, we can see a little bit more of that. Yeah, totally cool. Okay, so I will just now tell our jetway to come over. Yeah, obviously it doesn't work on this airport, so yeah, let's just skip it. In that case, I will imagine that actually jetway isn't working, and I will just open the door and air stairs, and release air stairs. So assuming that everything is fine and the ground has connected power to us, we'll just switch to ground power and turn off the APU and APU bleed and everything, so on packs, and turn actually off everything we have, including the taxi light, which I forgot to turn off. Sorry. And yeah, strobe lights, collision lights. Of course, I really can't do that pretty fast when I'm still driving an airplane. That's why airplanes have two pilots, one pilot, one co-pilot. So yeah, probe lights, everything is off, and let's also do some other things. And right now we can see almost all displays and lights are off, and we can just after that turn off the batteries, and still we have some power from the ground, and we will just release that power and turn off our connection to the ground power, and everything is off like before. So as you saw, it isn't a big deal to fly an airplane. Of course it looks some strange and complicated, but after just a few flights it's a routine. And if you want to be a little bit serious about that, you can use a virtual airline network, and they have some trainings. It's not a joke. They have real trainings for the pilots, because real pilots also use that to train and get their licenses, which is not so easy, and they will tell you that probably a lot of times. So as I said, my idea was to bring you to the simulation world. Of course I didn't show you our airplane from outside, because I'm not usually do that during the flight, but here it is. It has some logo. It wasn't actually, I was wrong. I selected Boeing 737-900, but differences are very little. There are few differences actually. So we can see Frankfurt airport in a full color and full view. It's our airplane. It's wonderful. It's beautiful. And if we go to our cockpits, ignore the sound. I don't know why we have some sound and from where, but actually we are turned off completely. So yeah, if you need any questions, and of course if you want another video of another airplane, also I recently learned how to fly. I mean, almost learned, because I have a few things that confuse me, but learned how to fly Airbus. It's strange that Airbus is actually easier to fly than Boeing. What I don't like about Airbus is even they have some, doubled, even tripled backup systems. I don't really like that much electronics, and everything is put all controlling on the airplane and deciding is switched to computer, actually not really much up to pilot. But Airbus have just a few accidents. Of course Boeing is longer in airliner the industry, but generally both airplanes are safe. And 737 is one, I think it's the best airplane on its time, and I'm sure that it is the best selling airplane of all times actually. So once you learn how to fly Boeing 737, you will not have problem to fly any airplane actually. Of course you need to practice a little bit, but it's okay. I will just open now a window. Oh, that's not a window, that's head-on display. I use that at night sometimes, but so it's again the stuff. Sometimes it annoys me Okay. No, never mind. Something is buggy over there. So I'm glad that you watched a couple of seconds of this video, and thanks for your attention. Goodbye.